Hi, ladies and gentlemen. Welcome to Science. It is Mrs. Abel completing another one of these videos, and that's what I'm thankful for today. Screencast-O-Matic, because it lets me create videos like these. What are you thankful for? Maybe sleeping in a little late, or maybe doing your science lesson at a different time than you normally would. Today we're starting Unit 3. We're only doing 3 lessons in Unit 3, 301, 302, and 303. So let's get started. By the end of class, you're going to be able to describe how a geologist uses fossils and describe ways to learn about Earth's past. How do they learn about the past using fossils? And before we begin, who remembers which type of rock can we even find fossils in? Is it sedimentary? Is it metamorphic? Or is it igneous? A, B, or C? Think about it in your mind. Which type of rock can we find fossils in? If you were thinking sedimentary, you were correct. Look at this picture. Remember, sedimentary rocks have a little bit of this and a little bit of that. They are just like a junk drawer filled with all sorts of stuff. Look at these shells. Remember, sedimentary rocks have shells in them. Fossils are a great way to learn about the past and what the animals and plants looked like a long time ago. They come in those sedimentary rocks. They tell us when, where, and how ancient animals once lived on Earth, and they tell us about the history of the Earth itself. Everything has a history. Even the Earth has a history. And there are many ways to find out and learn about what has happened in the past. Think about when you want to know something. Maybe you Google it. Maybe you read it in a book. But where do you think all of those things came from? We are going to learn all about Earth's past in Unit 3. Oh, how things have changed. Close your eyes for a minute. Picture what your exact town, what your exact location right now looked like hundreds of years ago, millions of years ago. I bet it wasn't a really nice house that you're in right now. Everything has changed. Look at Pittsburgh, Westchester, Philadelphia. From the long time ago photos to today, everything has changed. We all have a past. How old do you think the Earth is? 100 years, million years, a billion years? Let's find out. Hopefully this works for us. I am going to try to play this video right inside my own video. We will all watch together.
More than 1.5 billion people use the internet every day, and they search for all kinds of stuff. And good for them. We're all about curiosity here at SciShow. That's why we've worked with Google and YouTube to answer 10 of the most popular questions searched on the internet. This is the world's most asked questions. And today's question is, how old is the Earth? Our best estimate is that the planet is 4.54 billion years old, give or take 50 million years. It's taken scientists hundreds of years to narrow it down to that range. So the better question really is, how do we know how old the Earth is? Well, for a long time, scientists just looked for the oldest parts of the planet's surface and then determined the age of the rocks there. The thing is, Earth is always churning around the plates that make up its surface, forming new crust and recycling older crust into the planet's interior. So most rocks on the surface today are an average of 100 million years old. But geologists have found older rocks, mostly those that were once in the deepest layers of the crust but then got thrust upward before they could be recycled. The oldest of these are the Acastinices in northwestern Canada.
We learned about nice
the amount
rocks.
of radioactive isotopes of elements in the rock, scientists were able to estimate their age at 4.04 billion years old. But to find the oldest material of any kind on Earth, you have to go to Western Australia, where geologists have discovered crystals of zircon in sedimentary rocks. Zircon contains uranium, which decays at a fixed, predictable rate. So, geologists were able to use that to determine that the crystals are 4.3 billion years old. So evidence like this tells us that Earth must be at least 4 billion years old. But we've found even more clues to Earth's age in space. The moon isn't geologically active like Earth is, so material from its surface can be dated pretty reliably. And the moon rocks brought back from the Apollo missions have been found to be 4.4 to 4.5 billion years old. Since the moon formed around the same time as Earth, that helps narrow down Earth's age even further. Then there are meteorites, which come from lots of different sources in space, but many are leftover debris from the formation of the solar system. And sure enough, more than 70 meteorites have been dated to the exact same range as the moon rocks. 4.4 to 4.5 billion years ago. So you put all that evidence together and our little Earth is pretty old. So thanks for Googling that, and let us know in the comments what the oldest thing you've ever interacted with is.
What's the oldest thing that you've ever interacted with? And don't say Mrs. Abel. I am not that old. How cool that they mentioned meteorites, which is something that we learned about, being a similar age. So for over 4 billion years old, that is old. We are going to learn about Steno's principles in Unit 3. Nicholas Steno was an early geologist. He studied rocks and was able to generate 3 basic principles. Steno's principles describe various aspects of sediment deposits. Using these principles gives scientists clues to events that have happened in Earth's history. Sediment deposits. Say, what? What does this mean? How does it happen? Let's think about this. Sediment deposits. We've talked about this before. We know that sediments get dropped along when the water slows down because it loses energy. All of those little deposits start building up. That sediment's deposited. It starts building up layer upon layer, creating those sedimentary rocks. That's the last video I created for you. We know that sediments are deposited and create those sedimentary rocks. Fossils are found in the layers of those rocks. And don't forget about our pancake theory. The oldest pancakes are on the bottom and the youngest are on the top. Same goes for fossils. The oldest fossil is going to be on the bottom. The youngest will be on the top. Let's talk a little bit more about fossils. Oh my God, a fossil, it's a Blockbuster video. I hope you know what Blockbuster is. I used to love watching Blockbuster movies. On Friday nights, we would go to Blockbuster to rent a movie. The best. All right, fossils. They are a gold mine for geologists. They are the physical pieces that link the past to the present. They can provide information on the types of organisms and their behaviors. Scientists can compare fossils to determine the age of rock layers and events that happen in Earth's past. We're going to save that brain pop for another time. Take a look at this fossil succession. Fossils are used to determine the age of rock layers. Scientists use clues from the fossils, such as the order that organisms in the fossils inhabited Earth. This practice was first developed by geologists in the 1800s. They made principles based on similar fossil discoveries made in different areas. We are going to learn about these principles. What they're saying is that they found different organisms in the layers at different times. Remember, those oldest are going to be on the bottom, the youngest are going to be on the top, and they were able to use this information to help them discover more about Earth's past. What do we say about those pancakes? Oh, they look delicious. The oldest ones on the bottom, the youngest ones on the top. Records in rocks. They use that pancake theory, but it's all rocks and fossils. The layers of rocks in the earth provide a recorded history of that area. Each layer has different features. They contain pieces of information that tell scientists about past geologic events. Geologists apply the principles of rocks to the information they find in the different rock layers. This allows them to create a geologic history of an area. One of the goals of geology is to give an accurate description of the history of Earth. Scientists study fossils and rock layers to learn about events in the Earth's history. Once rock layers are dated, geologists are able to construct a history of the Earth and create a geologic time scale. The time scale is grouped into different parts of time, each characterized by different features. Take a look. These are the different eras. There was the Cenozoic era. They started seeing grasslands and horses and elephants, and then the Mesozoic era, when they saw birds for the first time. Dinosaurs! Who doesn't love talking about dinosaurs? Flowering plants, and look at my favorite animal, a flamingo. The Paleozoic era is when they had mammal-like reptiles, flying insects, land plants, starfish, and the Precambrian era, worms and simple plants. These are the different time eras. Here's a fun fact for you. The largest dinosaur fossil found was nearly 34 meters. It was a dinosaur called the Argentinosaurus. That's a really big dinosaur. It was found in central Argentina. I see where the name comes from. That's one pretty long dinosaur. No marine dinosaur fossil has ever been found, but they think that they existed underwater. Did you know? Well, now you know. So what is next? There's no homework. I want all of you to make it a great day, make it a great week, and make it a great quarter too. I believe in all of you, and I am always here to help you with anything you need. I know we are going to do amazing things this quarter. I look forward to finishing out Unit 3, completing our Unit 2 and Unit 3 unit test, and then we will move into Unit 4, which is really fun because we learn about the continental drift theory. And hopefully you guys all saw that really fun movie. I will talk to you all tomorrow. I hope you have a wonderful day. Remember, no homework. I will see you all tomorrow. We'll continue our journey learning all about Earth's history. Have a great day. Goodbye.